In this video we're going to look at interpreting graphs, okay, just to make sense of these graphs. I suppose this section probably lies in between coordinate geometry and graph theory, okay, or functions. I'll deal with it here though, as well as in graph theory and functions. Right, so we have a graph, and on the y-axis we have our distance from home in kilometers, and on the x-axis we have time in hours. Right, so let's say I wanted to, well actually let's just make sense of it first. It's probably someone on a bike and they're cycling, okay, and they cycle away from home, and they stop, they get no further, so they have to spend an hour there, but they're not after getting any further from home. And then they go a bit further from home, they end up actually 60 kilometers from home, and then they're back at 0 kilometers from home, which is actually their home. Right? So let's make some sense of this. Let's say I was asked what actually describe the journey of this guy. Alright, well I would say he started at his home, and then for 2 hours he cycled at a steady pace, and after 2 hours he ended up 20 kilometers from his home. Then he took a rest for an hour. He took a rest for an hour because, well, in that hour from 2 hours to 3 hours, 2 to 3, he actually didn't get any further away from his house. He's still 20 kilometers. Then he went cycling again. And in that hour, from 3 to 4, he actually travelled from 20 kilometres from his house to 60 kilometres. So he travelled 40 kilometres in that 1 hour. And then he didn't take a break or anything, he turned straight around and he cycled all the way back at a steady pace again. Okay? Now, so a few questions. How long did he take a break for? Or when did he take a break? Well, he took a break from the 2nd hour to the 3rd hour. How long did he take a break for? He took a break for 1 hour. When did he cycle the fastest? Well, really, the steeper the slope, the faster he's cycling. Okay? That's just something we need to know. The steeper the slope, the faster he's cycling. In actual fact, whatever the slope is will be his speed. Okay? I'll show you. So, let's say I want to find how fast his average speed was over the first 2 hours. Right? So the first 2 hours is this bit here. So how fast is he going? Well, think back on this. Distance, speed, time. I want to find his speed. So speed is distance over time. The distance he travelled is 20. The time was in 2 hours. It took him 2 hours to travel that. So he is 10 km per hour. Okay? 10 km per hour. Fair enough. Let's do the rise over run though. Well, he ran 1, 2. He rose 20. He ran 2. He rose 20. That's a slope of 10. Same. Watch this. Here's the point 0, 0. Here's the point 2, 20. If we slot those points 0, 0 and 2, 20 into our y2 minus y1 over x2 minus x1 formula, the slope formula, do you know what we get? We get 10. Okay, so whatever the slope is of these lines, that's actually the speed. Right. If I wanted to find his average speed here, I'd do the exact same. Okay, I'm just going to do it very quickly. Well, he runs 1 and he rises from 20 to 60, which is 40. So 40 over 1 is 40 kilometers per hour. And lastly then, turns around and he comes right back. So his speed is, well, he rises 1, 2, 3, so he runs 3, and he rises a negative 60. But remember, this is speed, so he can't have a negative speed. Okay? So whatever answer we get, we'll forget about the minus. So that is minus 20, which is 20 kilometers per hour. Okay? And again, just like I was saying, the steepest part, or the steepest slope, will be the faster he was going. And if we look here, what was his fastest section? Well, this bit here, he went 10 kilometers per hour. He stopped here, 0. This bit here, he did 40 kilometers per hour, and this bit here, he did 20 kilometers per hour. Alright, hope that helps, guys. So thanks.